Hello. Okay, so the point of this is just to give you a very quick introduction to Lab 5. It's a bit rushed because we were a bit slow on this one because we're getting the project ready and everything. So I'm sorry it's probably a bit later than some of you guys expected. But it should be fun because you've got Lab 4 as well, and that's due this Friday. And Lab 5's not due till week 7 Monday. So like you guys aren't going to worry about this for this week at least. I mean, obviously flexibility break, you don't have to do it. You got the weekends as well. So it should be fine. This lab is a bit quieter as well. It's probably 50-50 theoretical and 50-50 kind of code. Um, it's set up to be pretty trivial. So the way it's kind of done is that like you'll be making some pretty significant changes and it's not going to be easy, but there's nothing here where you have to go and write like 100 tests, right? So all the tests are written for you. Everything's pretty nice. There's a lot of hints about what you can do here. Um, and the point of this lab is to just kind of give you a problem like this, which is SSO, and I'll talk about it in a second, that's a bit difficult in terms of like you haven't seen it before. And so it's kind of trying to get you prepared for something like an exam, more like where you may be given a question that kind of does something very, very similar to the lecture content, but in a way that you've never seen before, right? And so you're not going to be given a question like this in an exam where it's like SSO, it's like a completely new concept. But you could be given something which is like, hey, this is very similar to like this lab, but we've changed it, we've twisted it, and now it's not so obvious that they're similar. And so you kind of have to make that connection. Anyway, so we're just going to kind of go through this. So the aims of this is obviously to apply state, strategy, and observer. I don't know why I said obviously. It's just that's the point of it. We want to work and modify an already existing, and I say non-trivial application. It's pretty trivial as an application goes. Previous versions of this were probably about 2 to 3 times longer in terms of like the code that was already there. The whole application altogether is actually quite small. Let me check. I mean, you can see how many files are here. Um, there's what 800 lines of Java code total, and most of that is tests, right? 500 lines of that is tests. So there's 280 lines of code that's given to you. I had to painstakingly write those tests. Regretting not making you guys write tests. But anyway, I'm too nice, baby. And so the point of this is that kind of you. I mean, honestly, actually, more than that is test because you also have this test file. So like, I think the code that like is given to you is probably like 150 lines max, and you're gonna be probably writing maybe an extra 150 on top, maybe 200, right? Like it's very little. I mean, what's an easy way for me to check without giving away the answer? I can just do this. Yes. CD Lab05. There's so it went from 700 lines of code to almost 1,000. So um, let's check out master. Yeah, so there's like 220 lines of code is how much I wrote here. So it's very quite small. And I probably overwrote it in places or wrote too much or whatever, and maybe there was some small changes I didn't have to make and that you guys won't be making. So pretty much, in compared to most labs, you're looking at a very smaller, much smaller subset of changes, and especially since you have like basically 2 weeks to do it. And so kind of the point of this is to for you guys to slow down. I don't want you to like go fast through this, and that's why there's a lot of theory questions, and there's actually a whole answers.md file. I'm not really a fan of like excessive theory questions, and that formatting is weird. It's not too weird. I'll fix it up, but like if you open up like this, it looks fine. It's just like it trying to auto format it. So it's just I know there's different ways you can do these tables so they format better, but anyway, fix formatting. I'll push out this change for you, so it should be fun. But anyway, so you can see the answers.md file, and this contains a bunch of stuff, including obviously this kind of diagram here, or this state table here, but there's quite a few questions. But each of these are only about a sentence or two. So this alone is not going to be like a 4-page report. It's like if it's more than like probably like 80 words, you've written too much for the entire thing, right? It's really just meant to be very simple sentences. What patterns can you see in the flow, for example? Like if there's two patterns you can see, say like those two patterns, right? Like you don't have to explain why you see those or anything like that. It's just keep everything very simple. Yeah, keep everything very short. The idea of this is just try to get you thinking before you start. So what I want you to do when you kind of study this lab is to read through this stuff. I'm going to explain this in a second now, and just try to like absorb it in and think about it, and kind of plan out what you want to do before you start. Because I think a big problem that people have when they're programming, and I see it all the time, is this kind of need to go fast. Like they get so stressed, they get so worried, they get so tunnel vision, they go 1,000 miles per hour, right? You can be a very, it's not about being slow. It's just about taking your time. It's about not stressing, right? You don't have to write code really, really fast. If you do that, you're gonna make mistakes and you'll end up being slower overall. I say that, but like I also rush, when you get time pressured and stuff like that. Okay, so let's kind of talk a bit about what the problem is. So it's a state strategy observer problem, or SSO. I thought that problem was kind of funny. And you're basically using two providers, Google and Instaham, which I think, too proud of Instaham. It's like a driver delivery service at Instagram one. Anyway, and so to help you begin, basically, we're just going to kind of discuss what SSO is, and kind of how it works, as well as kind of just gently breathing you into the starter code, and just checking I'm on a master branch, so I'm not going to show you solution. Yeah, so just to kind of give you a bit of disclaimer, this problem has been massively trivialized. And so it's not like, oh, wow, you have to build websites and do all this craziness. And oh my gosh, you have to do certificates because SAML is typically used for SSO. And oh my gosh, I don't even know what any of that means. I don't know what. No, it's none of that. It's very simplified. Very, very simplified. There's no web requests. There's not even a web. It's literally just like simulating kind of how the flow kind of works, but not really. And at the end of the day, it's not really like SSO, and it's much more like just having a login system. But like it really isn't like SSO really, but it's kind of just like, hey, here's an example that's kind of analogous and kind of makes you feel like it's something in the real world. Yeah, and so we'll kind of go through that and kind of talk about it, but it's decently close. It's somewhat similar to like an OAuth 2 pattern. And so what we have here is we have this concept of authentication versus authorization. So authentication is like confirming that someone's who they say they are, right? Like, for example, if you say your name is, I don't know, whatever your name is, I just blanked and couldn't think of a single name. I don't know, Braden. If I say my name is Braden, then to prove that, I can show things like my driver's license or whatever. And for a website, you can prove that you are who you say you are through the use of typically a username and password. And typically the password is kind of that confirmation. It's that cryptographic. It's that kind of security system in place to kind of ensure that the data has some kind of integrity to it. And in that, like, you are who you say you are. I don't know how else to kind of explain that simply. And data integrity is actually quite an interesting topic because it's actually quite important, and it's something that a lot of people make mistakes with, actually, funnily enough, especially in the web world, where you have like, hey, I have this like token that says you can access the resources on Facebook, and then people think like just like generating a random series of numbers is like secure. And like that's not necessarily secure. It's like arbitrary / random, or cryptographically secure, cryptographically random. But to make it have some kind of integrity to it, it needs to be like kind of resistant to change. So someone can't like go in and like kind of modify it and somehow like break that integrity. It's like somehow that code has some kind of resilience to it. And so, checksums and stuff are typically through that. I don't know. It doesn't really matter. Authorization is like, hey, I'm going to give you a set of permissions to resources or actions, right? Like, hey, yes, you have authorization to jump up and down. You have authorization to access this page on Facebook or whatever. You don't really need to know any of that. It's just kind of giving you an idea, some background context. Anyway, so question should be reasonably simple. A lot of stuff you can Google if you're really worried. SSO, though, the one thing that kind of the lab does talk about is this kind of idea of a universalized set of credentials across a series of applications or set of applications. And it's kind of like, hey, you could use your Google login to log into Gmail, to log into whatever kind of other websites. For example, you can use your UNSW ZID and password to log into GitLab, right? Now, that's not necessarily SSO. That could be something called external login. Like, it's not something called external login, but it's like an external login system. I think it's... I was going to say IDAP, but I don't... for some reason, I think that's like an email protocol. Is IDAP an email protocol? Or... apparently, it's something that... no, email protocol is something different. Yeah, there's an email format called IDAP. I don't know. External login. LDAP, that's what I'm thinking of. But then again, I could be thinking of something else completely differently. Yeah, LDAP is 100% what I'm thinking of. Close enough, I had the DAP. And so the point is that LDAP allows you to kind of have this external login. I believe that's how GitLab does it with your kind of ZIDs, but it's the same kind of system of having this kind of generalized set of credentials. And UNSW does actually have SSO. And the big thing about SSO is it's kind of typically has some kind of cache to it. So it means that if you go and visit my UNSW, then go visit Moodle, typically in SSO systems, because you logged into Moodle, you will also be logged into my UNSW. Does not seem to be the case with UNSW, but that's typically how it works. And so that's one of the reasons you log into Gmail, then you go to YouTube, and you're still logged in through that account, right? It's that kind of single sign-on. But it also can just be a generalized set. It doesn't have to be across the web. There may be a different terminology for that. Again, 8:30 in the morning, my brain's not working. I've been working hard at many things for many hours. I need some rest a little bit soon, so my brain's not going to be 100% up to all the specifics about everything here, which don't really matter. Anyway, so look at this kind of SSO flow. Whoa, what English was that? Look at this SSO. Look at this SSO flow. Jeez Louise. And the big thing I want to focus on is, oh my gosh, this is scary. I've never seen this before. But what does this kind of look like? And it very much kind of has this almost kind of flowchart look to it. And that's really all it is. It's what we call a sequence diagram. Now, sequence diagrams can get very complicated, and I typically use to kind of resolve parallelism as well. Like we have like multiple requests going at the same time and they can overlap. Oops. Let me just make sure my Teams not going to pop out of message. And all that kind of stuff. But in this case, it's very simple. And so what you do is you read from the user point of view, this kind of actor here, and you read left to right, and you just follow the arrows. And every time you read this alt, this is like an if condition. So it's going to go, okay, first I'm going to visit the app, then I'm going to check whether or not I have credentials. Have I already logged into this website before? If I've already logged into this website before, it's going to maintain that session. Typically, that session is maintained through something called a session cookie, which is basically just a cookie that can't be accessed through JavaScript. It typically is strict and same site. And we call it session because basically only the domain of the web server can access it. So basically only the application can access it, not the client side. That's quite important. Cookies nowadays are typically frowned upon in a lot of cases. Session cookies are still kind of seen as this like necessary evil. Mainly because you can have expiry dates on them and they're just very nice and clean. And typically they're quite secure nowadays with all the same site restrictions and stuff like that. And same site is like, hey, it's exactly what it sounds like. It's just like, is this the same site? So it means that you can only access cookies that you created, basically. So if we have a credential, awesome, we redirect back to the home page. Speaking is really hard this morning. If we don't have credentials, or they're non-existent, or they're invalid, or who knows what else. In this case, you guys really just have to focus on non-existent. Don't worry about invalid. In that case, you got to redirect to a login. And then the user is going to decide on a provider to use to log in. And then they're going to go and talk to this provider here. Right? And this kind of indicates the provider is only active for this little period of time. Right? And then the provider is going to go, okay, I'm then going to redirect all the way back with the correct access token because you logged in. Now, in our system, when we look at our providers, let me show you this. For example, Google, you'll notice that if the login is valid, so this is, we're checking whether or not we have users. Yes, we got a user for that email. And when we get that user for that email, yes, we have a password that matches the one we want, in which case we generate them a GUID, which is our very bad cryptographical kind of access token. Please don't do this. This is very bad. Apparently this is generated using cryptographically strong. Normally they aren't. Normally GUIDs aren't generated using cryptographically strong. But even though it's cryptographically strong, I wouldn't use this because you typically kind of want to salt it with something user related still. I don't know, maybe not, but it's still a bit clunky to me. I guess it depends what you're doing. This is probably fine since it's cryptographically secure. And it probably has enough entropy to it, but who cares? Let's not worry about that. If it is not valid, you'll notice it returns still a token, but the access token's null. To basically say, no, you can't access anything, but we recognize that you try to log in, right? This will make your life a whole lot easier, trust me, because it means that you can basically just take everything as a token, like, oh, I received a token, awesome, I can do something with this, right? Rather than kind of having to handle all these nulls, and it gets really clunky and stuff like that. And so that's what I mean by this access token. This could be null. So when we validate this access token, we're basically just checking, is it null? You don't actually have to talk to the provider to validate it. You can, if you want, you could add validation to the provider, and you'll notice that that kind of validation is done in Instaham, right? And I'll talk about Instaham a bit later, but you see that when we generate our user code, right, we actually go and we add the code. But we actually then remove the code once we get the token. So that's a bit weird. I don't know why I wrote it that way. I guess that's just a kind of a 1 a.m. brain is doing things that kind of are superfluous. Oh well. I'm sure there was a reason at one point. Maybe they were separate at one point, and then when they combine, you don't have that consistency. It really doesn't matter. You're not going to be modifying any of this code anyway. You're just going to be treating it as a black box. You'll be adding small modifications in classes, but you don't have to understand how they work. It'd be good if you understand kind of how to interact with them, but as you'll see, it really is kind of just focusing on getting you to apply patterns here and recognizing that kind of stuff. And let's honestly close others so that I don't give you any hints or anything. The inspiration of existence. Anyway, so what we have here is you get one class name. Ooh, spicy. You could kind of keep some persistence here. We do remove the user codes. Up to you. You could, I don't know, keep them. I don't really care. If you want to make a bunch of changes, go ahead, but I really wouldn't. And so you can just presume all tokens are valid. Yay, right? And so you can just basically be like, hey, if it's not null, it's valid, effectively. Now you could still get a null token. When this says presume all tokens are valid, it means presume that if you get an access token, if the login was successful, that access token is valid. It's not saying presume that every single token is successful. As you've seen the last part, the last section is all about unsuccessful logins. But before the last part, you don't have to worry about unsuccessful logins. You can presume that all logins are successful. Okay, if the user doesn't exist at all, you create the user and you link the provider. If the user exists but not under that provider, you link the user to that provider, right? And then we convert the access token. Again, this step is kind of abstracted away for you, and you don't have to do anything but just convert the access token, right? You can just keep the access token as it is. But that's actually quite common, is converting the access token. You won't see it everywhere, Google and Facebook kind of systems typically don't really do that, but some websites do, and it basically comes down to the fact that If you convert the access token, it's now you lose the ability to access things like the Google resources and the Facebook resources because you have your own version of it, right? And that can't access them. But it does mean that you're not constantly pinging them to like refresh the token, and it's much more integrated into your systems. It just simplifies everything. But again, that's just there for completeness. You don't have to worry about it, and then we redirect back to the home page. And so you'll see that the code that we give you actually implements this flow basically already. So that's kind of the point. We give you some bad code and we go, this is bad, fix it. And I go through an example flow. The user visits an application homepage. They aren't authenticated, so they log in. It was successful. It notices the user exists, but not with that provider, so it registers it for that provider, and then they go back to the home page, and that's the end of our mock simulation. Providers may require different methods to log in, and we'll talk about that in a second. There's only 2 providers in the system, and the token does not even have expires out. I actually removed that because I was like, it kind of just complicates things for no good reason. So I'll remove that before you guys see it. I forgot to remove that there. Okay, sweet. Now, if we keep going through, we get design here, and we can see if you do this before the coding part of the lab, yep, okay, just do this, and you can see here just some questions. Just answer them, right? Fill in the tables, do all the stuff, and just think about it. And you'll be like, oh, this is much quicker. So let's just look at one of the tests. Now, I'm actually going to look at one of the tests. It's the same test, but I'm just going to look at it here just because I think it makes it a bit simpler and because I want to show you that it passes with the given code. So this is the given code that we give you, and it passes, right? So what that means is that the given code already passes one test. It probably doesn't pass the rest. I'm almost certain it doesn't pass probably any of these. I mean, we can run it and see. And, oh no, oh, that's a lot of red, right? So that's kind of what you're doing. Oops. But yeah, obviously, okay. So let's have a look at this. There's no easy way to open that. Okay. What we're going to do is we're going to create a provider called Google. Then we're going to add a user to that provider. That says, okay, this user can log in through Google. And then we're going to go and add a client application. We're going to register that provider with that client application to say, yes, this app can use this provider. We're then going to go create a browser to let us browse the web. We're going to then visit this application. By visiting this application, it will go, hey, I can't log you in. You don't have any credentials. So it will cause us, some trucks are driving by. It will cause you to redirect it to select a provider because, hey, you don't have any credentials. You got to select someone. Then we select Google, say, hey, we want to log in through Google. And it goes, awesome. Okay, you're now using a Google login. Now notice the name of this. This kind of makes it tricky, right? And there's stuff like this, UI designers always love. And so when you do stuff like this is typically kind of where patterns kind of come in, where you can't just generalize the text out and you kind of need this kind of specific text and stuff like that. Not always, it depends. And then we're going to generate a form submission. This is a fancy way of saying, hey, we want to generate a token. So if we actually look at this, this will go and generate a token for us, right? Just as we know. And then this token will then interact with the browser. So what you'll notice is that we have this interact function. And if you actually look at the browser, you notice there's only 2 ways. Oh, there's only a couple ways for us to interact with this. There's basically only like 4 ways. We can visit a website. We can interact with that website. We can clear the cache, which I'll talk about in a second. And we can get the current page. So it's very little interaction. This is very important. You shouldn't be adding any more interaction, any more public functions. You can add more private ones, but no more public. And so what we see here is we've got a very encapsulated class. Now, whether or not this is good or bad is a different debate. And having this kind of generic object here is kind of probably a little bad. But the point here is to kind of say, okay, you're given this very kind of abstracted interface, and how are you going to implement it cleanly given this kind of weird constraint? And I kind of love giving problems like this because the point is that sometimes we can't give you like 4,000 lines of code to write, right? Where you actually have to test your design. So by giving you these artificial constraints, we kind of show you how a real kind of life system can be clunky and how you have to design code to kind of satisfy that clunkiness. And so this interaction function will depend upon the current page. And so you're basically going to be rewriting this in one of the tasks to be much cleaner, to maybe use a pattern, and we'll talk about it in a second. So the first thing always is that whenever you pass in null to interact, it always goes back one page. That's just fundamentally what it does. You can see it here. It has its kind of concept of a previous page and a current page. And it backtracks like this. And if the current page equals null, it revisits the app to basically just like reload the page. Because it's like, hey, I'm already at null. I can't go any further back. You don't really have to handle this case actually at all. It's not tested, but you could if you wanted. Funnily enough, I don't know. Like I'm sure there's gonna be little things like that, right? But don't worry about it. You can easily handle this case, like very easily. So it's kind of up to you. What we have here is we have the kind of concept of pages, as I said, and if you're on the current page for select a provider, then we only support Google right now, and we check that the current app has support for Google, and then we set the previous page and the current page, and in Google login, which is basically what this redirects to, we then interact and we give it a token, and if we give it a token, it sets the current token to this, it sets the current page to home, and it registers the user. Yay, okay, great. Now there's a bunch of problems here, and there's problems due to the fact that there's a lot of repetition of code here. Having this kind of previous current thing is clunky, there's strings everywhere, it's kind of messy. If I want to keep adding states, I kind of have to keep adding cases. It's hard for me to have interactions between components. I mean, this is obviously very clunky with Google. Do I kind of want to keep copying and pasting the same one for, Instaham and so on? I mean, there's only 2, but still. Has Google here, like, there's thousands of things you could do, right? And so don't get overwhelmed. Just look at the first task. And if you notice that, they're kind of paced quite nicely. Hopefully, I don't know, maybe. So the first task is, okay, let's not get too scared. I mean, obviously there's a bunch of stuff here. Let's focus on caching. Now, caching is not persistent, so you don't have to use files or you don't have to do anything crazy like that. You can just store the cache inside the browser class, right? And all you have to do is just have to remember all visits. So if I look at one of the cache tests, you see I log in for a user, I visit that website, I then select, sorry, I didn't say that right. I create a user, I log into the website through that user, as you can see here. I'm now logged in. The website has my user. I then revisit the page and you notice I'm still logged in. And the reason why is because of the cache. Awesome. So the cache should remember me for that specific page, or for, technically you could have like 10 pages cached, right? Or 10 applications cached, sorry. And so you need to figure out some way to cache them so that when you visit an application, if you have that cache, you don't just set the current token to null, and maybe you see whether or not you can use it. Okay. The clear cache function should completely clear the cache, and it's done on a client app basis, so you can literally just do like dot equals on the class and it's fine. It's like pointer basis, not a name, not anything special. It's literally just like the reference of the class. Thinking about expires at, that is also something that you don't have to worry about, so I will also remove that. Again, as I was saying before, expires at is removed. Sorry about that. I'll make sure that's removed. I thought I removed all of it, but sometimes these little things pop up. Yeah, so this is actually quite simple. It's really not that much code. I think it's, I mean, in my head, it's probably like 10 lines max. Yeah, if that. It's quite trivial. So the point is to kind of get your feet wet and try to see how it goes. So you don't have to modify a lot of the states. You're just kind of seeing, oh, where do I put my pieces? Where do these things go? And it should be all fine. The next one's a bit more scary, and what this is, you have to rewrite the page system and the provider abstraction to be nicer. And you may want to use 1 or 2 patterns here to kind of do that. And so start off with the providers, abstract those out, or you can start off with the page system. Actually, maybe starting with the page system is slightly better, up to you. And then once you've kind of abstracted out, you should be fine. You can see here, and it talks about what it does. Providers are typically pretty general. Think about what pattern you can use to represent the providers. And as you can see, Google is very hard-coded. Don't overcomplicate it. Keep it simple. And you can see about this null thing again. Now, I make a recommendation here to actually not look at this code too much. and to just try to make a git commit at this point once you finish task 2, and not to really think about task 3 that much, and just see whether or not you can implement task 3 without having to change a lot of things like the browser class or the client API or whatever. Can you just change like the Instaham classes and maybe 1 or 2 states if you need to, or whatever else you're doing, right? And if you can do that, then you're good, right? If you can't, it's still okay, but you've kind of taught yourself saying, oh, what did I think about? Because the thing about kind of writing code in the future is you want to kind of write it not so much to be like, hey, I've got to think about every scenario in the future. You just want it to kind of have a very high easeability of being refactored effectively. Anyway, let's keep going. Instaham is like a magic link authentication. So how it works is that once you try to log in to Instaham, so you can see basically the setup here, we then go, hey, we're interacting with Instaham, then we're trying to log in to Instaham. What will happen is after about 500 milliseconds, it will send a link to the browser. Again, this is big air quotes about send a link to the browser. It's like kind of fake and simulated. And then the browser will click on it and log you in, right? And so basically how it works is you bind the browser to the user here. And you say, okay, these two are connected. And then when you sleep here for a little bit more than 500 milliseconds, just I'm being paranoid, I guess, more than anything, you'll notice that eventually you log into home. And if you look at the code, you can kind of see how this event is done, and you can see the thread sleep 500 milliseconds inside of a thread counter that then goes off and triggers some kind of interaction event. And this interaction event is effectively what is like the browser clicking on something, right? This is literally what this is. The browser is clicking on the link using this code, something like that. So basically, in your case, all you have to do is call this function, and it will automatically, after 500 milliseconds, trigger the browser, and you're done. So like, again, the point here is not really to get you to write code, it's to get you to structure it. So you'll notice that like a lot of the code you write is structuring code, not like real code. I guess it's still real code. Anyway, and you can see I've repeated the function there, and a bit more explanation, blah, blah, blah. Make changes may seem scary, but don't panic. Focus on the small things first. Okay, locking is the final behemoth. It's the scary monster at the top of the mountain, the troll under the bridge. And it's not really that bad. It's definitely not a lot of lines of code. There's some interesting edge cases that you may be tripped up against and stuff like that, but typically you'll find it's pretty okay. And basically it comes down to if you log in 3 times unsuccessfully, you should get a locked screen, right? That makes pretty much good sense, right? However, it locks you for every app that uses that provider. So for example, if that same provider is used in 2 apps and you unsuccessfully log into one app, that same user cannot log into the other app, even using a different provider, regardless of the provider, as long as that provider is linked to both, right? And so I think the best way to kind of explain that is to show a test of it, right? Okay, here we go. So you can see here, I'm logging in unsuccessfully 3 times. This is an incorrect password. I'm running it 3 times, and at the very end, I'll be locked. Right? That's just what's going to happen. And my user is still registered. It still exists, but it's locked. I'm then going to go and visit the website again and interact through Instaham. This is a different provider than the one I originally used, but it's the same username. And the username is what links providers together. It's explained in the specification. So if you have 2 providers and you have 2 different logins with those providers, but they use the same username, they link. And so what that means is when I log into this user, right, it's okay if I'm logging in through a different app. So see app 2? App 2 only has Instaham and app has Hoogle. So I can log into app 2 only because it doesn't have access to Hoogle. So it doesn't know that my user is banned. So I can log in. All good. See, it doesn't have Hoogle, doesn't have access to it. As soon as I give it Hoogle, and then I revisit the page, bang, it hits us and we can no longer log in. And when we try to log in, we'll get a locked screen. Now, I clear the cache here just as a way to make it simpler, but if you see here, even with the no clear cache, you can see it still locks me instantly. Because my user has a cache login, it works. I can reset the page and I should log in, but that login is then locked. And there's no way to undo locks at all. So you can see that like the provider doesn't have to be originally there on the website to lock. As soon as it's added, it should lock. Jeez, it should lock. Okay, so that's basically done. And that's basically pretty much everything. So hopefully that's been a pretty good introduction. I don't really want to go any more overtime than this. This is kind of a 30-minute introduction, should be good. We've kind of gone through everything. And hopefully that will be all good. Awesome. Hope you guys have a bit of fun with this one. Maybe, I don't know. Maybe hopefully it's not too abstract or anything like that. And it'll teach you a bit of design. See you guys later. Bye.